So, like we said vectors have magnitude and direction. So you can actually find the magnitude and direction of a vector. We're going to do this basically in 2D. What's important to note is that the direction of a vector, that's kind of horrible. The direction of the vector is always measured from the positive x-axis. So basically this should remind you exactly just like polar coordinates, which is pretty much why we talk about polar coordinates in general. Not the only reason, but it's so you can talk about trig extra. So magnitude and direction. So if I had the vector, say, going over 1, 2, 3, up 1, 2, 3, 4, going like this, and pretending that was a straight line, of course, we've determined that we can call this vector 3i hat plus 4j hat. Now, I can find its magnitude, which is literally its distance from there to there, and I can find its direction, theta. And like I said, this is going to remind you basically of polar coordinates, because what you can think about is you can think about this point here being point 3, 4, and converting that Cartesian point into a polar point. So quite literally, you're going to draw in the triangle. Draw it in a different color. So you're going to draw on the triangle, sides 3, 4. You know this is a 3, 4, 5 triangle, or you can find it using the Pythagorean theorem. So this side here is 5. And if I want to find theta, I know that the tangent of theta is opposite over adjacent. So I can plug that into my calculator by finding the inverse tangent of 4/3. So inverse tangent of 4/3 is 53.1. So theta is 53.1 degrees. So in this case, I could say that 3i plus 4j has a magnitude of 5 and a direction of 53.1 degrees. So it's actually exactly like polar coordinates. So if you learned how to do polar coordinates, doing this is going to be a breeze. And if not, this is a great time to learn how to do polar coordinates because it's the same thing. Now, just like with polar coordinates, you have to be careful when using trig functions just to make sure you're in the right quadrant. So say this was 1, 2, 3, up 1, 2, 3, 4. If you were going to use trig to find this, 3, 4, and this would be 5, you could find again that this was a 53.1 degree angle, but you need to measure the angle from the positive x-axis. So it's really going to be 180 minus that, so 127. So you could say that negative 3i hat plus 4j hat had a magnitude of 5. Magnitude is always positive. Magnitude is always positive. It has a magnitude of 5 and a direction of 127 degrees. Okay, so there really isn't a whole lot more to this, especially in 2D. If you're familiar with converting polar coordinates, it's the exact same process. About the only way that we can have a little bit of fun with it is to do a 3D process, and I'm not even going to try to draw it out, but I'll just tell you. Let's pretend I had this. The magnitude, I'm not going to have you find the direction because that's a little bit more geometrically complicated than I want to get into. But the magnitude is going to be the square root of 3 squared plus 4 squared plus 5 squared. The idea is if you have a box, say 3, 4, 5, what you're finding is the distance from here to there, pretending that that was a straight line. It's probably the worst straight line I've ever seen, from that point to that point. So if it's familiar to you from geometry, great. If not, just memorize it. It's really not hard. It's just the Pythagorean theorem with one extra term in it. but it's the square root of 9 plus 16 plus 25. Come here. And if you're on a TID9, you need to put that little dot in there so you can get an exact answer. If I don't put that dot in there, it's going to give me that, which is fine, but if you put the dot in, you'll get the decimal answer automatically. So 7.07. Again, and don't worry about direction. Again, where you're going to see the most problems on this particular kind of question is if I said, well, what is this? What's the magnitude of... Just remember that when you find the magnitude, that you're going to put that -3 in parentheses before you square it. Oh, you know, just make sure you treat your negative signs well. So you would get, I can do this, sort of what that turns out to be, the square root of 18 plus 25, so 6.56, something like that. You can have, I guess it's important to mention, you can have a 0, so let's look at it in 2D right quick. So if I had something that looked like this, if I only had something in the I hat direction, 1, 2, 3, 4, 5, this would be just 5 I hat. If I just had something in the J direction, you know, that could be simply 2 J hat. And similarly, you know, just know that whenever you're doing this in 3D, you could have the same thing. So it's perfectly legitimate to have something like that. When you find the magnitude, it's just going to be 5 squared plus 6 squared. Because what you've really got is 5 I hat plus 0 J hat plus 6 K hat. And just like we did with polar coordinates, we can also ask you to find these backwards. So fully expect to get a problem, you know, where you're given, you know, a vector like this that's not really clear where it goes, but it says that this is 60 degrees, and it says that this length is, you know, let's not make it 60, let's make it a little weird. Let's say this is 55 degrees, and the length is 20. Then I would say, you know, find the IJ notation for this vector. So again, literally, you know, you've got to draw on your triangle. You've got an X term and you've got a Y term. I know that the sine of 55 is going to be opposite over adjacent, or sorry, opposite over hypotenuse, So y is going to equal 20 times sine of 55 degrees. 20 times the sine of 55 degrees. So 16.4. And similarly, the cosine of 55 is going to be adjacent over hypotenuse. So 20 times the cosine of 55 degrees. 20 times the cosine of 55 degrees. 11.5. Okay, so you just got to remember whenever you write this in I hat J hat notation that you've got a positive x and a negative y. So again, I'm kind of breezing through this because I feel like if you've already done polar coordinates, that this is just more of the same. It's just kind of an excuse to have you do it again. But vectors is really, really important, and seeing the connection between trig and polar coordinates and vectors is a really good first step in being successful, particularly in your first physics class.